Uh, so today is April the 7th, still winter. Um, we have due this week. All tutorials are due. Now this says the 9th, it should be the 10th. On the 10th, 8 a.m. Please get it in on time. I know it's like they're auto-graded, so what's the big deal? The big deal is if it was just one or two people that submitted a couple minutes late, then that's fine, but it's not. It's like 50 or 60, right? So for my, you know, mental health, there has to be hard deadlines, right? I have 600 students. There has to be a hard deadline. This is a lot of extension. So please get them in before 8 a.m. Okay. Uh, I guess that's it. We're working on grading assignment 4, and then you should be all set. So sometime after Thursday, I will update all the marks. I'll download them all from Gradescope, including the test 2, and then I'll send out an email, and you guys can verify that everything looks correct. And if there's any problems, let me know. Otherwise, today we're going to talk about, so we're done the course. I mean, there's another lecture on performance, but that's extra to the course. It won't be on the final. In fact, even functions as parameters, not on the final, right? So like lambdas and stuff, you won't see any of that. You could at most see like as applied to the standard template library when we pass a function in to say a sort function. But that would be the absolute most complex thing you would see from that lecture. So we're going to do today will be a review, probably be a bit of a short class. So if you have any questions, please do ask. Now we're going to go over the practice test. Everything that I say will be relevant, right? There will be marks directly tied to what I say on the final exam. So pay close attention when I say like, well, you should watch over this or that. That being said, not everything that's on the exam, you should study more than I say, because there will be other stuff there. Okay, so let's look at any questions before we get started. Okay. One intrepid student today in class. I sort of expected no one, to be honest, in this weather, but all right. The woo claps, I'm going to look into that. I'm not sure how, I don't know if I can download those questions. I don't know. I mean, it's my first semester using woo claps, so I'll see what I can do. If you don't see anything, feel free to send me an email reminder I tend to get, I'm juggling 10 things and then some of these things I forget. But yeah, I will look into that. So our final exam, this is part of the instructions that you will see on exam day. There are 44 multiple choice questions. The woo claps. So I don't know what it's like to sign in as a student, but I did look at it. And it looks to me like there's two types of sign in. Either you sign in anonymously or not anonymously. If you've signed in like through school, I will see your student number, email, all of that stuff. So I don't know about the nicknames whatsoever. If you signed in anonymously, then I'm sorry, I don't know. There's nothing I can do to tie your name to your account. Yeah, so there's 44 multiple choice questions. 28 of them are general knowledge. So similar to, I know test 1 and test 2 have been, focus has been on written code. Test 1 though did include like 4 multiple choice, just general knowledge stuff. And that's basically what you will find in this section. 28 questions worth 1 mark each, general knowledge, mostly from class examples and notes. but not tied to like a larger application. Um, and then followed by 16 questions. So the 28 questions are worth 1 mark. The 16 questions are worth 2 marks, right? So that means these are actually weighted slightly higher. And those will be on, well, similar to on test 1 and test 2, I gave you a bunch of classes that work together in a way that's similar to what we did on our assignments. And then I ask you to write some functions from those, right? And it's, I mean, this is literally, this test is kind of, did you write your assignment, right? Or how well do you understand your assignment? That's basically what this test is. The 16 questions are worth 2 marks each. Some of them will have part marks, right? So some of them will have 2 mark answers along with a 1 mark answer or maybe a half mark answer. Not all of them, but some of them. And, you know, if you're looking at it, it's out of 60 and we have 2 hours. That gives you 2 minutes per mark. So you should plan your time accordingly. It's not a lot of time to pause and reflect, right? Answer the questions you know, and then come back to the questions you don't know later. All right. No X11, no. X11 was, well, I mean, I guess the truth is the assignments get kind of, if I just focus on the stuff that I teach you, the assignments get a little bit boring. And I know people are going to complain, but X11, it was really meant to, like, honestly, this course is just tricking you into programming, right? It's just tricking you into sitting at a computer and solving problems, because that's how you're going to learn. And X11 is just a little trick to get you to sit there a little bit longer, and also to have something a little more impressive to show your employer. Also, that is what C++ is about. It's about putting a nice abstraction layer over something that's ugly, right? That's typically what you would do with the language. So there was a lot of reasons for X11, but technically X11 is not, I mean, I don't care about that. I care about the concepts you learned while you used it. Plus it's all boilerplate anyway. It's just, it's stuff that you should look up. You shouldn't memorize that stuff. You just look it up every time you need it. All right, so given the first multiple choice idea, access modifiers, right? So we're talking about public, protected, and private. And what that means. These should be kind of straightforward. In this case, we are looking at access modifiers along with the inheritance hierarchy. So in this case, we have a car with a public variable wheels, a protected variable doors, and a private variable pistons. And then we have an electric car that inherits publicly from car. And then we have a Tesla that inherits publicly from electric car, and then Tesla has some function. And inside the function, we're going to access these, right? We might say, I might give you a question like, which of these would not cause a compilation error? Right? So which of these statements could legally go in that space? And of course, well, wheels is public, so that's accessible anywhere. So wheels is good. We could put that there. Doors is protected. So when I publicly inherit, car publicly inherits from, or electric publicly inherits from car, inherits doors, doors remains protected. And then Tesla, when I inherit from electric, I still inherit doors and it's still protected. So I still have access to doors. Here, pistons is private to car. And so electric does not get access, neither does Tesla. So this one would be a no. And then, of course, down here in the main, I have Tesla, TS, and then I might say, well, which of these is valid? And in this case, only this one, right? This is main is considered, you know, you could think of it as a public square or whatever. So only public things are allowed there. So in this case, wheels, protected and private, would not be allowed. And then we might change something, right? So this is a very simple example, but I might say, what if we use protected inheritance here? What does that change? Well, in terms of what goes in the this location, well, wheels goes from public to protected, right? So it's publicly inherited into car, but when I inherited into Tesla, the access modifier for wheels becomes protected, which means I can still put it here. Doors also will remain protected. Pistons still private. So this part here, what goes in there stays the same. The difference is down in this main function. This is wheels is no longer public. It's protected. So technically, none of these would go there. All right. So then you should know that, and you should know if I use private inheritance, what happens then? And so all the access modifier stuff. Any questions on that? Okay. All right. My old standby, this is always on the final. I don't know, it's just a fun little example, but so I have a class hierarchy, animal at the top, right? So animal, and then I have bird, and then I have chicken, and over here I have cat and pig. So that's my class hierarchy. And then I throw a pig, and what's going to be printed out? Well, we have to think like a compiler. The compiler in C++ is very straightforward, right? I call it dumb because it just basically does the most basic thing you could think of. In this case, it's going to start at the first catch block, and it's going to ask, is a pig a bird? And the answer is no, so it's going to skip that catch block, and it's going to say, is a pig a chicken? And the answer is no, so it's going to skip that catch block, and it's going to say, is a pig an animal? And the answer is yes. So it's going to land there, and it will not get caught here. So this will output animal alert. And so yeah, it's a simple question, but it's kind of useful for that. Right, yeah, for throwing, you might have a bunch of exceptions in your inheritance hierarchy for your app, and so how you place the catch blocks is relevant. Of course, the way if we try to compile this, we'd get a warning. But yeah, questions on that? Okay. Copy constructor. Okay, so this is a little bit deeper, this one. But again, though, this is all multiple choice. So you're not writing this stuff, but you have to be able to read it and recognize when it's correct. And so what am I asking for when I ask for a copy constructor for this show class? Well, if you did an inspection of these classes, you would find that, we'll draw a little memory map. You'll find that they are organized something as follows. I have a show class, and my TV show has episodes. So I have a show, it has a name. If you checked, it also has a number of episodes variable. These are both statically allocated. They will be in the same place. They will be in the show struct, let's say. Then there is a double pointer to episodes. And we need a double pointer because what we do, right, if we look at the code, whoops, not this, that's not sorry, this code. If we look at the code, we're in the show class, and in the constructor, we new episode pointer 256. So what we did is on the heap, we made an array of 256 episode pointers. And this double pointer points there. And then when we add a show, right, so add an episode, sorry. When we add an episode, it makes a new episode and it assigns it to the next available location. It doesn't do a range check or anything. In the interests of space, that's been left out. So what happens when we add episodes is that, well, these episodes also go on the heap. So we get something like this with a pointer. Okay, now if I use the default copy constructor, well, the default copy constructor is going to copy everything in these memory locations, which means that I'm going to get a second show with the name will be copied, number of episodes will be copied. The double pointer is a memory address, and the memory address will be copied, so I'll end up with something like this. So now I have these two shows are pointing to all the same episode array and all the same episodes in memory. That's not what I want. If I'm making a deep copy, what I want is basically, when I say deep copy, I say basically we're saying take everything on the heap, make a copy of it, and then so I want to make my own array of episodes, and then I want to take episode 1 over here and make a copy of it. Episode 1, and then I take episode 2 and I make a copy of that. And so this is what I want to end up with. So that's my deep copy. So I have to make a new array, and then I have to make 2 new episodes that are copies of the 2 existing episodes. So there should be, at least that many calls to new. So let's go back. All right, let's write the copy constructor. Show ampersand S. Pretend that's an ampersand. So we have to name and number of episodes. Well, these are statically allocated, so we could also use member initializer syntax if we like. Num eps, I'm going to shorten that. Okay, so we copied those 2. Now we need our own array. We don't need to copy the array. That's sort of pointless. So we're going to make a new array, episodes, similar to what we did in the original constructor. This is an array of episode pointers of, well, we used a magic number here, which is not, a bad idea, generally speaking, but for this example, 256 is our magic number. And then we want to, so at this point in our memory, we have this. We don't have the episodes copied yet. So now we want to loop over this array and make deep copies of all of the episodes into this array. Okay, so let's do our for loop. I is less than, well, I've already made a copy of num eps, so I can use either this one or the one from the show that I passed in. I plus plus. Let's put another squiggle. And then in here, I'm just going to say, well, episodes at I equals new. If there's no new in here, this is not a deep copy. Now, episode has a default copy constructor, so I can always use that unless it gets deleted somehow. We haven't really talked about that, so it always has a default copy constructor as far as we're concerned. So we want s.episodes at I. But actually, this returns a pointer, and we want a reference, so we want to dereference that. Okay, so that's our deep copy. And right, on a multiple choice question, I almost think I don't know for sure, but it almost looks harder to me, right? Because every question I show you, every answer is going to kind of look right. If you're just going by pattern matching, it's going to be hard to tell them apart. You're going to have to understand all these little details, right? So for instance, there might be two versions of this that look exactly the same, one of them with a dereference, right? And if I do that, probably if you miss the dereference, you'll get part marks, but yeah, I don't know. Pay very close attention to detail on these questions. But any questions on that? Okay. Order of constructors. Can we use the add? Yeah, but I mean, you're not writing it, right? So yeah, well, you couldn't. See, to add an episode, I have to pass in the name and the captions, and these are private. So add episode would not work in this case. Again, I'm giving you the solution, so you're not going to have all of these choices. You're going to have to recognize when something is correct. But yeah, out in the real world, using add episode in this case wouldn't work. Of course, these would probably have getters, but yeah. Okay, constructor calls in our class hierarchy, another detail, so I call animal. This is statically allocated. The constructor, the default constructor gets called for me. So definitely I know the first thing that gets printed out is this. The next thing we do is we construct a bird. Well, a bird is, I mean, it's part animal. It inherits from animal. And so everything in C++, everything in your class hierarchy gets the constructor called on it, right? Everything for your, whatever your particular object is composed of, every one of those constructors will get called, whether it's the default or whether it's a written constructor. So animal constructor and bird constructor will be called for bird. The question is which order? And anybody want to take a stab at it? Which comes first, animal or bird? Yeah, exactly. Animal is first. So it's always the base class first, similar to composition, right? We can think of it as a bird that contains an animal, and the contained object gets created first. So animal constructor, followed by bird constructor. And then the destructors would be the reverse order. So bird, destructor, and then animal destructor twice. Okay. And then we might throw something a little and then a third animal constructor for destructor for this one as well. Then we might throw a little, right? I might throw an egg class, which you don't see here, but assuming we had an egg class that did the exact same thing, you just print it out when the constructors were called. And let's statically allocate one of those. Now careful, because statically allocate means the egg constructor gets called. If this is just an egg pointer, then it doesn't. So do be careful about that. But assuming that I have a statically allocated egg constructor, that actually, says egg constructor when you call it, then when would that get called? Where would we insert that into the order? Well, this is actually a call from bird. This is a call from the animal. And this is a call from bird. And so the egg is also going to be created inside the bird, but it's going to be called just before the bird constructor and after the animal constructor. All right, so those are, again, details that are, generally speaking, you can ignore them for most of the time, but then every once in a while, it becomes very important which order these are called in, especially when you're doing complex things in the constructor and the destructor. But yeah, so questions on that? Okay. How would you change the function signature and write the setters to implement cascading in the date class? Cascading, I think, Christine, who just wrote a textbook on this, I think she prefers chaining. I like cascading. I don't know. But they both mean the same thing in this context. So assuming I have a date, D, and then I want to set the date, so I'll say set year 2025 dot set month for, and then maybe dot set day. So how would we change these function signatures to allow this? Well, as they're set up, of course, well, this first call would work. But then when we try to call dot set month, well, this set year returns void, so that's not going to work. Set month must be called on a date object, so we want set year to return a date, but not just any date. We actually want it to pass this date. We don't want to make, if we return by a value, we're going to make a copy. We want to not make a copy, we want to pass by reference. So we would do date ampersand date reference. And then we would do that for all of them, right? So these would all become date reference. One day I will learn to draw an ampersand. So yeah, that's it. To enable cascading or chaining or whatever you like to call it. Questions? Okay. All right, so this class hierarchy, now this is going to be a review, so I'm going to really skim these topics. And if you need a little more detail, please let me know. But of course, this has to do with multiple inheritance, where the things that I am inheriting from, human, and this should be horse. Goat is, what is it called, a fawn or something? I don't know. If you know your mythology. So centaur inherits from human and horse, and both human and horse inherit from animal. And this UML diagram is, we're sort of abusing UML notation to represent memory, right? So what I'm saying here is that, well, there is animal is back in the class hierarchy somewhere, and there's only one instance of it. Actually, let's take a look at all right, so here we have a class animal, and then we have a human that inherits from animal, and we have a horse that inherits from animal, and then we have a centaur that inherits from both human and animal. And you can see here we use the virtual keyword. And what the virtual keyword does is, well, when the compiler goes and compiles it, there are two ways that this could be resolved. The fact that there's animal in the ancestry of both human and horse. And one way is that the compiler says, oh, both humans and horses inherit from animal, but they do it virtually. So we are going to combine those two base classes, right? So then we only have one version of animal, and my centaur has only one name. The other way to do it is that, if I go back here and I take away this virtual keyword, now human and horse don't inherit virtually from animal. Now our memory model looks something like this. Again, this is, typically you don't use UML for memory models. So now I have two distinct animal ancestors, which means that my centaur has two distinct names, right? So a question I might ask is, given this class hierarchy, how many names does my centaur have? Or how many variables, how many member variables in general? So in this case, I would have 4 member variables. Feet here, feet there, name here, name there. If I use virtual inheritance, well then, I have 3 member variables. I have feet, and 1 instance of name. Okay, so in terms of memory, that's important, whether we use virtual inheritance or not. Questions on that? There's another detail that can come up, and that is, how do I initialize it? So, well, if I do not publicly inherit, or sorry, if I do not virtually inherit, in this case, horse does not virtually inherit from animal, which means that when I make my centaur class, well, I always have to call the constructor of my parent. Or, unless I have a default constructor and it gets called automatically, but the point is it always gets called. I can call it explicitly or not. And then the horse will call the animal constructor, right? Because, well, if we're using non-virtual inheritance, then I'm going to say, call the horse constructor, and the horse is going to call the animal constructor and initialize it. And I will call the human constructor, and then the human calls the animal constructor and initializes it. However, if I'm not using virtual inheritance, or sorry, if I am using virtual inheritance, then there's only 1 instance of animal. So if I try to initialize animal from horse and human, then the compiler doesn't know which one of these values it should use. So instead, I have to initialize it from centaur. So if I use virtual inheritance, I have to call all of the constructors all the way up the hierarchy. If I use regular inheritance, I only call my parent constructors, right? And in fact, in this case, it won't allow me to call this constructor directly. So that's another little detail that's, somebody has a question, I will get to it. Exactly. If you don't use virtual inheritance, you get 2 copies of the parent class, precisely. Yep. And then that has impact on how many member variables you have and how you access them, right? In this case, we need to use the scope resolution operator to tell the compiler which name we're referring to. But also in terms of construction, there is a difference. All right, other questions? Okay. How would we implement the plus operator? What if we wanted to implement? So the plus operator, well, the key to that is it's got to return a time object, right? So I want to be able to do something like time C equals A plus B, where A and B are time objects, which means that this should return a time object that is the sum of A and B. And well, the key is that I want to do that by value, right? If I want to overload the plus operator, not by reference. The other thing it asks is about this double equals operator. Well, the thing that's special about it is that, well, I can compare a time object to an int. And so let's say that I had time t1, and I had int t2, and I want to compare t1 to t2. But of course, there's 2 different ways to write it, and they both should return the same answer. But one of these can only be implemented as a global function. The other can be implemented as a member function or a global function. So out of these, 1 or 2, which one must be implemented as a global function? How do we know when to return by reference or value? Yeah, that's a good question. You always return by reference when in doubt, except for a couple special cases. The plus operator is one of them. The other one is the postfix increment. There might be more than that, but generally speaking, as a rule of thumb, you always want to return by reference unless you have a good reason to return by value. So yeah, it's not a question of which one should I choose. It's the question is, should I return by value? And the answer is mostly no, but occasionally yes. So one way to know is just to, really just to memorize it. To deduce it, you would use a B has to return something. The C. What does it return? It returns a time object that is the sum of A plus B, but I don't want to change A. New time object, I have to make a local copy. And if I return a local variable, I have to return by value, which means not by reference. So that's, again, the quick and easy way is just memorize. Plus return by value. And A, like the postfix plus plus, also return by value. Plus A is return by reference. I don't want to really go into all of those details. I can at the end of class if you like. But yeah, other questions? Oh yeah, which one of these must be global? And I guess why would be irrelevant. So let's consider what it means to be a member function. And this is a binary operator, which means it has two operands. So it's a function with two arguments. But when we write it as a member function, one of the arguments is implicit. I don't have to explicitly pass in the this parameter. If I wrote an operator double equals, then inside my parameter list, I only need one parameter. Since the left-hand side operand will be this, will be a time object, then the right-hand side operand will be an int. So the question of whether or not I can make it a member function is the left-hand side operand an instance of the class that I want to make it a member of? And if it is, then yes, it can be a member function. If it is not an instance of a time class in this case, then this must be a global function. Right, so this one, if I wrote the friend declaration, bool operator, now both of these operands have to be passed in explicitly. The left-hand side operand is an int, and the right-hand side operand is my time object. And then there should be a couple constants in there, but I'm going to leave them out in the interests of space. So yeah, the rule of thumb is the left-hand side operand. If that is the thing that I'm writing the function for, then I can make it a member function. If it is not, then it has to be a global function. All right, questions? Okay. So yeah, there's again, there's sure to be a question on this. I might give you a couple things like, I might say which of the functions up here is called if I do this. So yeah. Additional multiple choice things, hints, what things are represented in a UML diagram. Now this is what are not. Now I'm very flexible about, some people are very, I guess. It's important to follow the rules sometimes, but like a UML is a communication tool between you and another developer. And when you're communicating, like rules are meant to be broken, right? So, but what generally speaking, things are not represented in a UML diagram, that's a valid question. And generally speaking, what we don't include are getters, setters, constructors, destructors, and collection classes, okay? Those are generally speaking not the types of things we're trying to communicate in a UML diagram. We're looking at a higher level than that. We know everything has a constructor and a destructor. Well, in C++, it has a destructor, and getters and setters are sort of like implementation decisions that we make. All right, what are object design categories and what are some examples? Entity is, of course, our simplest object category. It is like a database entry. There is also collection. So if I want to store a bunch of entities together, I would use a collection class. There are control classes. So this controls the flow of my program, my application, sorry, and boundary. Boundary we can think of as like a view class is a boundary, right? So this sort of looks like a model view controller type thing, and that's valid, but boundary is also just anything where my application talks to some other, either a library or it doesn't even have to be, I mean, it could be a file system. That's talking to a file system is, if I have an object to do that, that's a boundary object. So yeah. What are some design patterns and where might they be used? So just the very simplest stuff, like facade. That's what I couldn't think of yesterday. What is a facade pattern? What is observer? Right. So factory. Those are the simple ones we looked at. Don't worry about visitor. Visitor is it's just a mess. I don't know. It's like I keep trying to explain it and never works. But yeah, so facade, observer, factory, strategy. Obviously, we used strategy. You used strategy in. I can't say strategy today. You used strategy in your assignment 4, so you should know that one as well. Basic iterator use. Somebody asked me, what does that mean? Valid question. So basic for loop, right? So if I said, oh geez, something, let's write a for loop. Auto, just to be lazy. IT equals, let's say we had a vector of something. So vec.begin, that is the iterator to that it at the beginning of my vector. IT not equal to a vec.end and IT plus plus, right? This is a loop over a vector of whatever, let's say strings. And so then you should know if I said cout, right? Like maybe I give you an initializer list. So this is Al and this is Bob and etc. And so then I do something like this. Well, an iterator behaves a lot like a pointer. So if I dereference it, that will print out the string. So you should know, you should understand everything I've just done here. And then because this is a vector, I could also use pointer arithmetic, which means I could do something like this, +2. Right, so this will, just advance the iterator twice. And then obviously we would get some sort of, if we ran it like this, we'd get some sort of out of bounds error, but so yeah, just basically that. Questions? Okay, should know very well what is the difference. I know how hard it is when you're learning this stuff, because I used to do the same thing, right? So what is the difference between dereference, address of, so like this? Maybe that's closer. Address of and this pointer. So when do we use these things? And when I was learning, I did the same thing, right? Oh, it's not compiling, so I'll add an ampersand or a dereference, and then it compiles, and then I just leave it. I don't touch it anymore. But this, you should learn this stuff. It does sink in after a while, and it does become second nature. So there are marks that hinge on your understanding of when you use a dereference and when you use an ampersand and when you use this arrow, as we will see in this part. G-clef, yeah. That's what it looks like. I don't know. I have no idea how to write it. It's crazy. It's just, all right. So this part, application programming, we're going to run through. We're going to write a few of these functions to give you an idea of what to expect. First, let's look at what this involves. So there's a bunch of classes. I'm going to sort of outline how they, a little bit how they interact. What you see on exam day is going to be very similar. Obviously, different names and stuff, because I don't want anybody just slightly different, possibly slightly different functions. But we have a movie class, we have a standard definition movie and a high definition movie. The movie class is abstract. Standard def and high def are not. I have a movie flicks, which is like my control / collection. It contains multiple movies that I may want to watch at some point, and then I'm going to take some of these movies and put them in a playlist. And that playlist, in order to access them, I'm going to use a, what is it called, a criteria. I believe on your assignment it was called a search, and it has a function called matches. And what that does is that, well, I give it some criteria and I say, like, does this movie meet that criteria? And if the answer is yes, then I can put it in my playlist, right? So we have these classes plus two different types of collection classes, an array-backed list that is a templated array, that will be the master list, and then a linked list, which will be our playlist. Okay, so questions on that? All right, let's take a look at now. I gave you this code. It's up on Brightspace. There's the example 1 through 4. I mean, you could ignore. I think some of this is just past examples that I was using. But in order to study, I'd recommend taking this and kind of doing the things we do today, and then plus like write the rest of the functions. And if you understand how all of this works together, and really this is a simpler version of assignment 4. So, Anyway, we have a movie class that is an abstract class, right? Function virtual. So we want to be able to, for instance, do something like this, M, where M is a movie, and well, whether it is a standard definition movie or a high def movie. That doesn't work for a global function because we cannot use polymorphism in a global function. So we're going to use instead this virtual play function, which we can use polymorphism in. So let's write this operator. Okay, and then so in order to print my movie polymorphically to the stream, I would just do something like, what am I going to do? I'm going to say m.play OS, because I cannot make a global function polymorphic. It doesn't make any sense. But this play function is a virtual function, and this does give us polymorphism. So if I ask you to implement this play function along with polymorphism, this is what you would write. All right, questions? Okay. Here's a criteria. This is an abstract class. We have one concrete class, but generally speaking, this is just if you want to test it. You could assume there's any number of concrete subclasses of this, but we're mainly going to be using the abstract version. So one of the things you're going to write code for is a linked list. This is a singly linked list. On your assignment, you did a doubly linked list, but for your exam, know how to implement a singly list. And I'm going to just going to add a constructor here. Think it's like for some reason I can never remember what I did. Maybe I just try and forget it. But I think I give you a constructor just to make the rest of the code simpler, right? So the linked list functions are a little bit longer than the average. They're about 5 or 6 lines long, whereas the other ones are 2 or 3. And so to help you keep it short, I give you this constructor. So what we're going to do for our movie list class, we're going to write this add function. This adds at an index, and we're going to change this. Actually, we'll leave it void. It's fine. If it was Boolean, we could return true or false, but all right, so movie list, add index. Okay, first thing, bounds checking. So int size. So there's a size variable you should add to your code. If you're going to study using the code that I gave you, I suggest making these minor changes. Otherwise, it's really hard to, I mean, there's ways to do it, obviously, but if I want to do bounds checking, if index less than 0 or index adding, so greater than or equal to size. Be very cautious with these, right? So there might be questions where, I give you one that is greater than or equal to, and one that is greater than, and one of them is with fewer marks than the other, right? So in this case, I'm out of bounds. So let's just bail. Okay. Greater than or equal to, because add, right? So technically size is the next available location, but that's a valid location to add something. Anyway. All right, so now we're going to break it down for clarity. Clarity over cleverness. So we're going to look at 2 distinct cases. One is we add at the front of the list, which is if index equals 0. We're going to add at the head of the list, which means we have to change the head pointer, right? So actually the first thing before we do any of that, new node equals new node. We can pass in the movie. So now we have a node that we want to insert, and we want to insert it at the head of the list. And so new node next equals head. Now, I believe, again, in the interests of keeping these a little bit shorter, you might have instructions like just pretend there's at least one element in this list. In fact, for this code, it doesn't matter whether or not, if the head is null pointer, this is still going to work fine. But generally speaking, I'm not really interested in trying to trip you up on those edge cases. I want you to understand the I guess bulk of the code here. So new node next equals head, and then head equals new node. That's it. That's how I add it, and then I can return. And if there was a Boolean, I would return true. Okay, so that's the first case, index equals 0, questions. Okay, since I did a bounds check and since I've eliminated this case, down here, index is greater than 0 and valid. Those are two. Oh. All right. So now we want to add something to our linked list. Let's go back to our memory drawings. This is our linked list, singly linked list. Everything has an implicit index. Right, so this is index 0, this is index 1, this is index 2 and 3. And then I call add movie at 2. All right, so the first thing I want to do is I want to make a new node that contains M. And where I want to insert it is here. I want to take this pointer and point it to my new node, and this pointer and point it up here. This now becomes index 2, this becomes 3, this becomes 4. So that's what I want to have happen. In order to execute that, what I need is a pointer to this guy. So I'm adding M at 2, and I need a pointer to index 1, which means I want to traverse the list until I get to that index just before where I want to insert it. Okay, so let's write that traversal. I'm just going to use a simple for loop. Again, index minus 1 will take just the right number of steps, right? So if my index is 2, I'm going to take 1 step from 0 to 1. If my index is 1, I'm going to take 0 steps because, well, that's perfect. I want to be at the head of the list. And then plus I. And then, oh, well, we need a pointer to the current node. And then we're going to traverse the list current. Okay. So this brings us to where we want to be in the list. And then if we jump back here. So now we have current pointing to here. This is technically current next for the moment. And this is new node. And so what I want to do is new node next equals current next. And current next equals new node. And that will stitch that new node in there. So, and actually the order is important, but you know, not to get you too distracted. New node next equals current next, and current next equals new node. And that's it. I'm done. I've added it, and then I can just return or leave it. If there's a Boolean return value, I'd return true. But yeah, questions? All right, be very careful. All right, obviously the questions that I give you, a lot of them, a lot of them are going to look very, very similar to that. They can fool you, right? They can fool your brain. Say, yes, of course, that works. I highly recommend drawing a picture when you're answering these linked list questions. But of course, it's up to you. All right. You should also know, I mean, remove at index will be very, very similar to this. Not exactly the same, right? We're deleting, and but we would essentially want to walk up to just before the thing we want to delete, and then we can do a bunch of pointer redirections. Template array. Now this is, for some of you, this is going to be, wow, like super simple. I don't even know why you asked this. But over the years, of marking written coding questions where I ask, write the constructor for this templated array class, and you would not believe the stuff that I've seen. So typically what happens is that if you've like done any of your own work whatsoever, this will be sort of easy. And for those that haven't, this looks like a nightmare of notation. And let's just write the craziest stuff you've ever seen in your life. But basically, this is a constructor. We want to initialize all of the member variables, which are these. So num elements equals 0, or we could use, the member initializer syntax. And then this elements, well, we want to, it's a pointer, but we want it pointing to an array. We want a new t, and then there's some sort of max function constant. New t. Yeah, so it just we're going to make an array on the heap of whatever it is that the user is storing. It's simple, right? Very simple, but yeah, just wow, just the wildest stuff in the simplest of these functions. But anyway, questions? Okay, you should also know how to write, well, let's write this one as well. Also very simple. Also, for the most part, people do fantastic if I ask them to write this. And then there's a few just outlandish answers. Right. At index, well, obviously bounce checking is important. If index is less than 0 or index greater than what? Num elements, max array, 0. Yeah, num elements. Again, sort of. What are we going to do here? We're going to exit. But one, if you didn't actually write this and tried to memorize it, then you can get confused. And two, I mean, you can just get confused, right? So again, on multiple choice, attention to detail will save you a lot of marks, right? Don't just write the first thing. I mean, the first thing is a good instinct, but be very careful about that, the syntax and the notation. Max R. Is that a pirate? So it's not max R, it's num elements, right? So num elements is from 0 to num elements is like the valid range, the things that we've stored. Max array is the number of things we can store. But otherwise, just return elements at index. Should you dereference? Should you use the address of? Well, the answer is no in both cases, but I've seen all of those things. Okay, questions? You should also know how to write this, the plus equals, right? Add something to the back of the array if there's room. The minus equals, that's a little harder. Now you have to, well, I mean, you have to know how to read the code, right? So this is actually quite valid. Asking you to write it is, I think, a little bit nasty, but asking you to read it and recognize which one correctly removes something, I think that's valid, right? So in this case, you would have to find this thing and then take it out and then close the gap after. Yeah, almost done. So movie flicks, now we have add movie. This would just make a call to the factory, get movie, remove movie. You should know how to write those, right? Basically, for the most part, you're just forwarding calls to this master list. There's some of the comments here say profile because I originally had some different ideas, right? So this is one of the reasons why, yes, well, I mean, you're right. In this case, that's not always true. Anyway, anyway, you are correct. I would be, um, sorry, what was I saying? I can't remember. Anyway, we have a master list. Oh yeah, some of the comments don't actually match, right? So that's the danger of over commenting your code, is that your comments turn into lies when you change your code. So minimal comments is that's one of the reasons why I like minimal comments, so that when I make a change, well, you just read the code, like it's right there. It's not that hard. All right, so we're going to write the add to playlist function because that uses every class that we've seen, right? So what we want to do is we want to loop over the master list and find all of the movies that match this criteria and add them to the playlist. All right, so let's write it. It's also like really not a complicated function. It's quite simple, but it uses everything, which is kind of nice. I like questions like that. Const criteria. Okay, so what we do now, again, the concept is simple, right? But because this is multiple choice, I might be trying to fool you with similar looking syntax. I less than movies. Now, I'm in an IDE and I get this autocomplete feature, which is kind of nice. You're not going to have that on the exam. What you're going to have is you should take a look back at this movies class. You should see, oh, it's an array. Look back at array and see what functions you have available, because I might try to fool you, right? I might put a function that doesn't exist because because I'm mean, I don't know. Because I want you to pay attention to these details, right? This is obviously in an IDE, you can kind of get away with it, but it's at some point we have to test your understanding of this stuff. So yeah, this is a for loop over a movies array, calling get size. So make sure all those things are valid. And then would say if, well, crit.matches. Matches is a member of the criteria class, not the movies class. All right. Again, this is one of those details. It's going to look the same when you read it, like at a glance. It's going to look correct, but make sure that you have the correct classes, the correct functions being called on the correct classes. All right. Because what I'm trying to do is I'm trying to separate the people who are just doing pattern matching from the people who actually understand what to do. And one way to do that is to give you patterns that look very similar to the answer. But be careful. Here I want to grab movies at I. Again, subscript. If I look at my movie array class, I have a subscript operator, so this is good. This actually returns a movie pointer, however, because that's when we made the array, we made it of movie pointers. So each instance of T is replaced with this pointer. So I need to dereference it, right? In my IDE, that gives me all these hints that make it easy. On the final exam, there are not these hints. Please read the stuff carefully. Because yes, the questions are designed to try and fool you. Then I want to add it to the playlist. So playlist dot, well, there's an add back function. And that takes, well, it actually takes a pointer, right? If we go back to this class, add back takes a movie pointer. So I do not have to dereference it in this case. Right? So this is a short, simple function, but it touches on every class and there's a lot of detail there. And yeah, you're going to see every answer is going to look basically like this at a glance. So make sure you understand these details. But that's also one of the reasons why these are the questions that you get. They're worth 2 marks and you might get part marks if you, if you get the dereference wrong or whatever. All right, questions? Okay, also know how to write this one and print movies. Any of these are valid. And again, any one that I ask, the details, the devil will be in the details. We'll see. I don't know. It almost looks harder when it's multiple choice, but we'll see what the marks look like after. Okay, well, that's it. I'm going to stop there unless somebody has questions. I can stick around after class to answer any questions, but in general, for those of you who showed up, and I know it was a nasty weather out there, but thank you for showing up all semester. I appreciate it. I don't mind that people take advantage of watching the videos, and that's why they're there. But it's also nice to have people to interact with a little bit here or there. So yeah, generally speaking, so again, watch out for an email to confirm all of your grades. I am around. Thank you very much. That's very nice. I'm around all week usually. I come in every single weekday. Basically, you can catch me in my office from like 8 to 3, well, probably 3. The earlier you find me is better. So if you have a question that takes 5 minutes, you can drop in anytime. If you have a question that takes longer than 5 minutes, email me and make an appointment and we can set something up. But yeah, otherwise, if I don't see you this week, then I will see you at the final, and good luck on all your other final exams. And and hopefully when it's all said and done, there's some sunny weather after all of this.